Hey everyone, let's round out our conversation about RIPng by taking a look at reintroducing a new topic that we covered pretty extensively in RIP version 2, and that's going to be the idea of default routes. Yes, IPv6 supports the concept of default routes in the context of our RIPng protocol. What we want to do is look at exactly how we are going to implement that and follow it through on a step-by-step basis. And here's how we're going to do that. All right, so clearing out the material from our previous discussion, what I want to do is make certain, first of all, that everything is operational in our environment. So show IP interface brief E assigned, and I still have this interface down. So config T interface serial 2/1 no shut. Now the other thing is I need to remove any of my offset lists. Do show run interface serial 20. Interface serial 20, and what I want to do is I want to remove this offset value. Do show run interface serial 21. Shouldn't be anything configured on it. So now, if everything goes right, I should be able to start load balancing to reach that destination one more time. Also, I should be able to see it in my routing table as having both the destinations, and they should be with a metric of 4. All right, now, what I want to do is, again, I'm really getting keen on this idea of scenarios-based instruction. So let's look at a scenario and see how it's going to be impacting our operations with regard to RIP next generation, and the concept is going to be the idea of a default route. Well, what I want to do is I want R1 to generate a default route. Now that default route that I'm going to generate is going to not be the 0.0.0/0 prefix. It's going to be the ./0 is what we're going to actually be originating. Now, how do I do that? Well, let's make that work on R1. And it's going to be under the interface configuration. So what I'm going to do is I'm going to create a default route. And what I'm going to do is I'm going to go under interface E00, do show CDP neighbor out E00. That's going to connect me to Cat1. So under the interface E00, what I'm going to do is I'm going to type IPv6 RIPng for the process, and the other option that I'm going to have is default information originate. So let's do that. Let's say default information -originate. Now, it's default information, but the next command is the originate, and now what I have the capability of doing is specifying a metric. So let's say I want to do a default information originate of 6. What am I doing here? Metric 6, sorry. Enter. Now, what's going to end up happening is if I start looking at my infrastructure, first of all, will I see a static default on R1? Let's look at that. End show IP route. Says the gateway of last resort is not set. Also, what I want to point out here is, let's see, show IP route pipe include null 0. Notice it did not create a null 0 route. So advertising it is just like in RIP version 2. It doesn't have to physically exist to be advertised. So basically this is just a hack over the process. We're going to find out when we start talking about like a routing protocol like OSPF, the prefix has to exist unless we use keywords to override the normal behavior, where we can say, well, ignore it if it doesn't exist. So we have this concept of always advertise it, whether it exists or not. RIP is going to do that by default, and there's nothing that we can really do to change it. Nor is it going to create a default route to null, or a static default route to null, a static route to null that's going to prevent loops. So again, keep in mind, RIPng is just as perilous with regard to doing this operation as RIP version 2. But what we want to do is let's go over to R22. Show IP v6 route. And let's see what we have in this table. Notice right here, we have a default route. This is what a default route looks like in IPv6. Now, the idea here is that this default route is going to allow me to send information to R1 if I do not have a corresponding match in my topology that's going to allow me to send it to a known destination address. So that's the whole idea of a default route. So as a perfect example, if R1 was connected to the internet, it could advertise a default route rather than having to advertise every route that it needs to learn from the internet to operate. Something that RIP version 2, RIP version 1, RIP next generation would never have the capacity to be able to support. Also, we need to understand that when it comes time to using these protocols, we have to understand other elements involving things like redistribution, where we're going to have careful consideration associated with things like metrics, because remember, OSPF or EIGRP may have a metric in the millions, where RIP is going to have a maximum metric of 16. So anything above 16 is going to be considered to be an infinite route. So all I did is just the basics with IPv6. We'll entertain and do more with IPv6 in the future, but right now this is sufficient for our understanding of how RIP operates in RIP version 2 and in RIPng, and this should cover everything that we need to know in order to have a very, very good opportunity of dealing with anything that we could get asked in context of the Routing and Switching version 5 exam. So with this being said, I'm closing out RIP, and I'll see you guys in the EIGRP videos. Get up, take a break. You guys are finally to the end of a subject. I'll see you on the other side. Bye-bye.